Hi, my name is Dom Grisafi, and I'm here to discuss my paper, The Variability of Visual Field Loss on Vision-Specific Quality of Life in the Multiethnic Ophthalmology Cohorts of California Study. You can reach me at domgrisafi@gmail.com. These are our disclosures. As people's visual field worsens, their quality of life specific to their vision decreases. This has been known for some time, both intuitively and in the literature. So in this study, we would like to ask quantitatively how much visual field loss is associated with a clinically meaningful loss in vision-specific quality of life. Then we would like to know which domains of quality of life are most affected. There are several different ones we'll discuss. And finally, we would like to ask both of the previous questions for our different racial ethnic groups in our study. We have population-based cross-sectional studies of African Americans, Chinese Americans, and Latinos. Here is a map of our study area. Here's LAX and downtown Los Angeles for reference. In Inglewood, California, we have the African American Eye Disease Study, AFEDS. In Monterey Park, we have the Chinese American Eye Study, CHES. And in La Puente, California, we have the Los Angeles Latino Eye Study, LAILS. These studies were conducted over the previous 20 years, beginning in the early 2000s with LAILS, and then in the early 2010s, CHES, and most recently, AFEDS. Visual field loss is the main exposure in our study. On the left, we have an example of somebody with normal visual field. Here is their field analyzer. White indicates high vision, dark low vision. This is the physiological blind spot, which is normal. However, you can see that they can see both centrally and peripherally, and they can detect this pedestrian in the crosswalk. In contrast, on the right, we have an example of somebody with visual field loss. They cannot see in this particular area, which is characteristic of open-angle glaucoma. What's more, the brain fills in the image for them, so they are not aware that they do not see the pedestrian. You can imagine how dangerous this might be for somebody with this pattern of field loss to be driving. In our study, we do not look at the particular area of the field loss, but we take the overall total mean deviation in the better seeing eye. The more negative the number, the worse the visual field. Quality of life can be a somewhat difficult concept to define. One definition is a set of outcomes that contribute to a person's well-being or overall health. Health-related quality of life is within the context of an individual's physical and mental health. More specifically, we can look at quality of life just related to their vision. Psychometricians and ophthalmologists have done a lot of work to show that VSQOL is really made up of two subdomains. Task, what is your functional ability, what can you accomplish with your vision? And well-being, what is your social emotional role? How do you feel about yourself because of your vision? And how do you interact with others? We measure vision-specific quality of life using a survey instrument called the NEI Visual Function Questionnaire 25. It is composed of 25 items shown in schematic form here. Traditionally, we take these items and organize them into 11 subscales and take an average score. Then we can look at high-resolution domains of quality of life, such as driving difficulties, mental health, and role function. However, this analysis relies on some heavy assumptions that we have shown are not met in our dataset. To address this, there is a new form of analysis. Item response theory is a more robust analysis for scoring the NEI VFQ 25 that relies on less assumptions than classical test theory. We've organized 13 items into the task domain of quality of life and 12 into the well-being. We will use these as our most quantitative, accurate measures of vision-specific quality of life. We used hierarchical linear regression modeling to estimate the association of quality of life and visual field loss. Of the 17,000 people that participated across all three studies, about 14,500, or 85%, had complete outcome and exposure data. We included many of the usual suspects of epidemiology as potential covariates, such as age, sex, etc. Of note, the African American cohort was much more likely to be born in the US than either the Chinese or Latino cohorts. This is a useful proxy for acculturation that was available in all three studies. In addition, the African American cohort had higher education, was less likely to be working, had greater income, more health insurance, and a greater number of comorbidities. The Latino cohort was about 3 times as likely to be depressed than the other two, and the Chinese cohort was about twice as likely to have visual impairment than the other two. We included the logMAR score for visual acuity in our models to try to isolate the association of visual field loss and quality of life independent of other measures of visual function. This is our first outcome for vision-specific quality of life, the task domain with item response theory. Quality of life ranges from 0 to 100, 100 being the highest quality of life, and deviation ranges from about 0 to -30, -30 being worse visual field loss. We can see right off the bat that there are differences across the cohorts. The Latino cohort has a lower starting point for 0 visual field loss compared to the Chinese and African American cohorts. However, as we continue down the associations of our lowest plots, we can see that the Latino and Chinese cohorts are about parallel, and the association for the African American cohort is weaker. It is not as steep. This means for the same amount of change in visual field loss, the quality of life decreases at different rates between the African American and the other two cohorts. Here are the beta coefficients for the linear regression model of task and visual field loss. We can see that for the Latino cohort, for every 1 decibel of visual field loss, there was about a 0.75 decrease in quality of life. And so on. The Chinese American cohort was similar, slightly lower, and then the African American cohort was much lower. We included an interaction term between cohort and field loss to assess whether these differences were statistically significant. There was no difference between the Latino and Chinese cohorts. However, the Latino cohort was different from the African American cohort, and the Chinese American cohort was also different from the African American cohort. Here is a similar low-S plot, but for the well-being outcome of vision-specific quality of life. Initially, we can see that the intercept for all 3 cohorts is lower for well-being than for task, suggesting that among people with no visual field loss, their socio-emotional quality of life is lower than their functional task-related quality of life. In addition, the results are more gradated. The Latinos again have the strongest association with quality of life and visual field loss, but the Chinese now have an intermediate between African American and Latino. This suggests that for the same amount of visual field loss, Latinos are more impacted in their well-being quality of life, followed by Chinese Americans and then African Americans. Here are the beta coefficients from the linear regression of well-being on visual field loss. We see that the Latinos again have the strongest association, and then the Chinese Americans, and then the African Americans. Again, the Latinos are not statistically significantly different from the Chinese Americans, but they are statistically significantly different from the African Americans. However, what is new is that the Chinese American cohort had no statistically significantly different association from the African Americans, unlike in the task domain. So the previous results might be useful for an epidemiologist, but what might a clinical provider be interested in knowing? We're going to rely on 2 prior pieces of information to explain the clinical importance of these results. First is from a paper from the Lales cohort from 2004 that found a 2-line difference in visual acuity is associated with a 5-point loss in quality of life. We will use this as our definition of clinically meaningful. So to transform our betas from the previous slides into these clinically interpretable results, we simply divide each of them into 5. The second piece of information is that visual field loss is often categorized into mild, moderate, and severe based on cutoffs of -2, -6, and -12. So here are our transform results, which suggest that for Lales and Ches, the clinically meaningful difference in visual field loss is about 6 to 7 decibel change. In African Americans, it's a little more. It's about 10 decibel difference before reaching clinically meaningful losses in task quality of life. These are all moderate visual field loss. In well-being, it's a little more. It's about 7 to 8.5 for Latinos and Ches. But in African Americans, it's not until 13 decibels of visual field loss that you're having clinically meaningful changes in well-being quality of life. And this is a severe level of visual field loss. Here we have a forest plot that summarizes our findings from before. On the x-axis are the beta coefficients, so the larger the beta coefficient, the stronger the association between quality of life and field loss. And we see those similar patterns where Latinos have the strongest association, followed by Chinese American, and then the African American community had the smallest associations between quality of life and field loss. And then we also see that task were stronger associations than the well-being for all cohorts, indicating that as field loss worsened, the task domains fell faster than the well-being. Now these are summaries that we've already shown, but we would like to now take this chance to look at classical test theory subscales to see which subscales are really driving these changes in task and really driving them in well-being. So the most important one for the African American Latinos and the third most important for Chinese was driving. So driving by far and away, especially for the Latino and African American cohorts, was impacted most with field loss. Next was role function. This is things like do you accomplish as much as you would like to and in a timely manner because of your vision. This was the #1 association in Chinese Americans. It was also up there for Latinos, but not so much relative. But it was almost not significant for African Americans, indicating that Chinese Americans really felt like they were losing efficacy because of their vision. Mental health was in the top 4 for all 3 cohorts, so we think this is the most important well-being subscale of quality of life that is impacted by field loss. And then specific to the Latino cohort only, dependency was the #2 after driving for Latinos, indicating they felt like they relied on other people because of their vision more than others. And finally, the African Americans tended to report things that were more related to task, like near vision and peripheral vision, suggesting that their functional losses are what they feel the most with visual field loss and not so much their well-being, with the exception of mental health. Finally, we were interested in assessing whether visual field loss had a variable impact on quality of life, not just by cohort, but also by age. So we did another linear regression model with an interaction term for age greater or less than 65 years. And we found only one outcome was significant, and it was for driving. Those that were older, indicated by the dashed line here, had a stronger association with field loss and quality of life. Perhaps this is explained by some sort of protective effect amongst younger people. Even though they may be losing visual field loss, they are not as inhibited from being able to drive. And this was significant for all 3 cohorts. So what are the implications or takeaways from our research? First, we found clinically meaningful differences in vision-specific quality of life with mild to moderate visual field loss in Latinos and Chinese Americans, and moderate to severe visual field loss in African Americans. Next, we found that all racial ethnic groups had 2 subscales of quality of life in common: driving difficulties and mental health. And then we found an interaction by age for the association of driving difficulties and visual field loss, so that older people tended to feel the impact more than younger people. Finally, we found subscales of quality of life that were unique to each racial ethnic group. In Latinos, they tended to feel visual field loss impacted their dependency on others because of their vision. Chinese Americans tended to feel that they were unable to accomplish what they would like in a timely manner because of the visual field loss. And African Americans tend to report more objective vision losses such as near vision and peripheral vision, and seem to be less impacted by socio-emotional domains of quality of life. What are some of the limitations and future directions of this work? Cohort was a proxy for race ethnicity because in order to be eligible for these studies, participants had to self-identify as each racial ethnic group. However, as you saw, these studies were conducted over different distinct time periods, and there is complete separation. So maybe time period is really responsible for some of the observed variation. In addition, the cohorts are completely distinct by the cities from which they occurred in. So maybe there's some geographical reasoning for the variation that we are attributing to race ethnicity. However, we think likely these are minimal since it's within the same county, and truly it is race ethnicity that is explaining this variation observed. Finally, we have to wonder, are these results valid for other people in other parts of the country? For example, African Americans tend to have higher education and income in California. However, we do believe that these are marginal differences and these associations are valid for other groups. We would like to recreate these models and these studies in large groups of people that have the same disease, for example, primary open-angle glaucoma. So we can look at the race-based differences within diseases. But unfortunately, this is likely not possible without extremely large cohorts because the prevalence of these eye diseases tend to be small. In order to get a population-based sample, we would probably have to sample the whole state. We'd like to thank those that have supported and been involved in this research. We'd like to thank USC School of Gerontology. I'm on a training grant through them. Would not be able to do this work without them. In addition, I'd like to thank those at USC Roski Eye Institute and the Southern California Eye Institute at Hollywood Presbyterian Hospital. Teams there have spent many years collecting and designing these studies, and they've been supported with grants from the NEI and from New York Research to Prevent Blindness. Would also like to thank all the participants of the study. Would not be possible without them. And finally, would like to thank the Knights Templar for their travel grant that I was unable to use due to the unfortunate circumstances with COVID, but would like to thank them nonetheless.